Hey, today we're going to talk about how we can change the rate of a chemical reaction. Before we do that, I want to explain to you what collision theory means. And recall for a moment that the kinetic molecular theory stated that a warmer particle moves faster. Well, the collision theory kind of does exactly what it says, or sounds like. It says that for a reaction to occur, particles need to collide or have collisions with the proper orientation and speed so that the reaction may occur. Now, there's a few ways that we can change the rate of a reaction. First of all, we can adjust three different factors. We can adjust the temperature, we can adjust the concentration, and we can adjust the surface area. So these three criteria are what we would be adjusting in order to change the rate of a reaction. Now, when we look at the temperature, first of all, according to the kinetic molecular theory, warmer particles move faster. Well, if you move particles around faster, chances are they're going to bump into each other more. So increasing the temperature will also increase the likelihood of there being a collision. Now, if we increase the concentration, let's just give an example right here. So we have a beaker, and we have another beaker. Now we're going to have two different particles. We're going to have green, and we're going to have red. Now with these particles moving around, eventually they would come into contact with each other. But if we increase the concentration, we're going to increase the likelihood that there will be more collisions. For example, if we had that many green particles and an equal amount of red, or close to the same amount, we're going to have an increased likelihood of there being a reaction over here where it might be 2.0 molar, as opposed to over here where it may be 0.5 molar. So again, increasing the concentration is going to increase the likelihood of there being a reaction. Now, one that kind of is a little bit confusing to some people is increasing the surface area. So I have right here a cube that is 2 centimeters long. So I have a blue cube that is 2 centimeters by 2 centimeters by 2 centimeters. So the entire surface area is 2 by 2 by 2, or 2 by 2, which is 4, times 6, which is 24 square centimeters. Now, if I were to break this apart, or crush this, so that I would break it up, instead of it being a 2 centimeter long side, it would be 4 1 centimeter long sides, or in fact 8 smaller cubes. So this is one cube. Now if I broke it up into smaller pieces, or 8 cubes, each smaller cube would be 1 square centimeter on each side times 6 sides. So that would be 6 square centimeter times the 8 cubes would actually be 48 square centimeters. This one, 24 square centimeters in surface area times the 1 cube is actually 24 square centimeters. So if you have more surfaces to react, you're actually going to have a higher probability of there being a reaction. Okay, look over here for your practice problems. I will not give you credit unless you've done the practice problems. So answer the questions if you want credit. Peace.